Right. Hi, okay, Defn episode 5. Hi,
Hello,
DJ.
Ray. How are you?
Right, I'm very well, yeah, very good. It's a good Sunday. And I'm actually, I don't know about you, but I'm missing the football, the European Cup final to do this podcast and dedicate our time towards Clojure, rather than watching the French and Italians beat it out for Euro 2016.
I'm from India. I don't care about football. When if it's not cricket, then we don't care. So it doesn't matter.
Okay. Well, Wales got knocked out, so the Brits don't care anymore either. Yeah, there was a Brexit. There was a big, heavy Brexit in the Euros. That's for sure.
Yeah.
Anyway, yeah. So just a quickie follow up. Apparently, we're still number 1 on the Vegetarian Clojure podcast rankings. In fairness, there's only one in that ranking, but we're still at the top.
So this is the challenge to the vegetarians of the world who are into Clojure. So you can still beat us up. So let's see if somebody does it. But we're still the number 1, so that's pretty good to know.
We're throwing it down. Yeah. We're throwing it down.
And we've been getting pretty good feedback, I think. Also, we have a new channel on Slack as well. So if you want to complain or let us know, just find us on Clojurians Slack and chat with us. And if you have any ideas for the shows, we'd love to hear it. That'll be great. So speaking of which, we had some follow-up from Alex, right?
From Alex Miller. After the last podcast, we were talking about potentially being a bit more open and transparent about the process. And Alex said, actually, Alex offered to come on the show and talk a bit more about it as well. So I think we'll definitely queue that up. So that's a great offer, and definitely we'll follow that up, I'm sure of it. He also recommended having a look at Maria Geller's video from the last Clojure Conj, talking about a look behind the curtain of the ClojureScript compiler. And I've got to say, I hadn't watched it until he mentioned it, but I watched it this week, and she did a great job, I've got to say. I'm very impressed. I mean, number one, I think she said she'd only been doing Clojure for a few months, maybe 6 months or something, or even 4 months, before she started doing this work on the compiler, which is freaking amazing in my opinion. So she's obviously smart, but she's a great presenter as well. She really makes it very easy to watch. She explains things very well, and then she ends up talking a bit about how the contribution process works as well, which is good to know. I still think there's more detail to be had from that. I still think that we can go into more detail with Alex about that kind of stuff. But I'll put the link to Maria's video in the show notes because I think she did an awesome job there.
And
so some other news.
Yeah. So the news we are going to Euroclojure, and the Euroclojure this year is going to happen in Bratislava in Slovakia, and the tickets are on sale.
Did you buy your ticket actually?
Did
you buy your ticket?
So I don't think so, because I'll be traveling with my wife as well. So we both of us will be there for a week in Slovakia, and of course the Defn will be there, right? I think you got the early bird one, right?
I got an early bird one, yeah. Absolutely. I think I got single figure tickets.
You know what? I'm a vegetarian, so I don't really eat worms. So early bird gets the worm, and I'm okay. So that's fine. I'm being a late bird. I'm happy with the fruits and stuff. But so I think it's going to be a blast, I suppose. So we'll be there, and hopefully we'll catch us. Maybe we'll do a special episode there if we can drag our equipment there, the whole microphones and everything. So we'll see.
Well, I'm going to bring my son along, actually. I'm going to bring my 16-year-old son. He just finished school recently. And I'm going to get him to be my multimedia lackey. He doesn't know that yet, but at least I'm hoping. He's definitely agreeing to travel with us. He thinks it's just going to be a holiday, but I'll let him know a bit later that he's actually going to have to work for it. Yeah. But so far, he just thinks it's a great end-of-school trip. So,
okay.
Hopefully he won't listen to this podcast and find out there's a nasty surprise waiting for him. Right, anyway, okay, so we'll definitely be there.
Let's get on to the show. So I know we promised we're going to look into asynchronous programming and stream thing, but as you know, we are very flexible and agile, and we are one of the most awesome podcasts ever. So we decided we're going to make it even better. So what we did this time is we're going to discuss Hoplon. And I have very very less knowledge of Hoplon. So I thought it would be better to, of course, I know Ray has given a presentation in Belgium meetup, and I hear that it's a roaring success with half a half a dozen people showing up.
Carefully selected crew, I think you're talking about here. Highly curated.
It's like
exactly. The elite of Clojure in Belgium. Yeah. Actually, to be honest, it was one of those things where I didn't know enough about it, so we're going to do a little trick now.
So we decided, because instead of two less intelligent people speaking about Hoplon, we decided we're going to bring in the experts. So on that note, I'd like to welcome Mr. Micha Niskin.
Hello.
Hey! Hello, Micha.
Hello, world. How's it going?
Pretty good.
It's going
Welcome
great.
to Defn.
Happy to be here.
Yeah, so...
all right, good.
We need to tell you that we are the world's best, or obviously world's best podcast of vegetarian Clojureans. So welcome to the world's best vegetarian Clojurian podcast. So are you into vegetarian food?
Actually, you told me, Micha, that your favorite food is a vegetarian food. Is that right?
Absolutely. Yeah.
Yeah.
I would never want to participate in some cut rate vegetarian Clojure situation. Only the best.
That's good to know.
Exactly. This is the best one. So you're on the right podcast for that.
Yeah. You can meet the challenge.
Tarnish my reputation with substandard vegetarian
podcasts.
Yeah,
that's
true.
You
wouldn't want to know about those guys. Yeah. Thankfully, we haven't got a splitting of that particular group yet. Maybe I'll just edit this out, actually, because we're going fucking nowhere. Anyway, no, leave it in. All right, good. Micha, come on, let's talk about Hoplon. Micha, tell us, just before we go there, Micha, I know this whole Hoplon story started a bit before your current work. So can you tell us a little bit about you and a bit about kind of like the Hoplon story, where it all came from? What was the origin story of this technology?
Sure. Alan Dipert and I have been friends for a long time. We met in the Army, and we served together, and later, and we both were we were not doing a computer type job. So we were the only kind of computer people there. So we became friends, and later we were working together in 2011, 2012 at this place, The Fresh Diet, where we made food and sent it to people. It's like a 250,000 lines of PHP type of situation. And so some of the things that they needed to do, we just couldn't do it, and we decided to, make our own solution. And we did.
Did you have experience of Clojure before that, or was that something where you decided to, where you first learned it?
Yeah, Alan actually demanded that I try Clojure. I was doing some stuff with Scheme at the time.
Ah, okay.
And I remember he was like, Scala, you should look at it. It has reduce. It's awesome. And so I got the book, and on page 120 they were still introducing new syntax, and I was like, don't ever talk to me again about any of this nonsense. And the next thing was Clojure. And I was like, oh, look at all that syntax. I don't know, dude. But it turned out to be the best thing ever. So yeah, I've been doing Clojure for.
It hasn't got that much syntax, does it?
No, but I mean, compared to Scheme.
For just a moment here, it's just compared to Scheme, yeah. But it depends which version of Scheme you're talking about, because that's still got. Yeah, okay.
Yeah, that's true. I mean, I'm not complaining. Clojure's great, and it's improved the quality of my life. My actual day-to-day living is actually way better because Clojure exists, because most of my time is spent programming, and Clojure is way better.
Yeah.
Yeah, you've got a lot more options, haven't you, with Clojure than you had with Scheme in terms of libraries and all those kind of things.
Yeah, and just the engineering is Alan and I were talking about reference types, comparing to ML and stuff, and just the engineering of how reference types work. That you have this. Whatever, you have a defined semantic for updating a mutable thing, and that you could watch it if it's a mutable thing. It's amazing engineering, stuff like that is all throughout Clojure, and I learned a ton just looking at Clojure.core, like about computing.
Yeah.
Right. Yeah. Like the whole STM thing is just phenomenal, isn't it?
Mm. Okay, let's get into the topic of the hand. So we have this. I know that you guys are working really hard with different kinds of libraries that you're releasing. I know you're busy with Boot and a lot of amazing things that you guys are building. But for this podcast, we'd like to discuss something more about the Hoplon framework and the whole libraries behind it. So there's this trio of trilogy, not a trilogy, but the three holy trinity of Hoplon, I would say, like Hoplon, Javelin, and Castra. Yeah, the pillars.
Ooh, three pillars.
Three pillars. So let's talk about Hoplon. So where did Hoplon come from, and what is the fundamental aspect behind it? So I know that there are lots of web frameworks out there, starting from jQuery and history. You did a lot of DOM related things. So can you give us some quick overview of Hoplon, what it does?
Sure, yeah. I mean, maybe like a tiny little intro to like our state of mind. Alan and I both throughout my whole career up until I discovered Clojure, I would make these applications, and every time it would get to a certain point, like usually I would release the thing, the first iteration of it, to like the stakeholders and whatnot, and they would look at it and make changes, and as soon as their changes started coming in, things would start unraveling architecture-wise. Like you add, magical arguments to your functions, like special case 1, true or false, that kind of stuff. And pretty soon, like you're at paralysis mode, which is where we were at with this PHP application, where making any change is like this death-defying thing. But with Clojure and with Lisp in general, like I feel like we're actually solving problems. Like Javelin, we haven't updated it in years now. Like we haven't needed to add any features to it. Like we just solved the problem, and that's all we need, and like that's it. And I'd never experienced that before. And so when we discovered this, we were like, man, so it makes sense to invest in making frameworks and things, because we could just do it once, and then we use it for the rest of our careers, right? To do stuff, to get other jobs done. And so like one thing we noticed at the Fresh Diet was that an inordinate amount of our time, like developer time, was spent, dicking around with the UI, getting the UI to work, and something that's trivial, like when you click this button, that other thing should disappear, but then this other form should show itself or whatever. And it was so hard to do it and took so much time. We were like, it makes sense for us to make some kind of framework, because we believe that it can actually be a solution that will not be like, So
PHP.
Yeah. So.
But PHP is on the server side. So I mean, on the client side, you have jQuery. So why would you want? I mean, okay, forget. This is pre-React, isn't it? This is pre-Angular, pre-all those
Angular
things.
was around.
So why wouldn't? Oh, was it around? Okay. So why would you reject? Maybe it's harsh to say why would you reject them, but why did you say, okay, well, Angular or jQuery or Ember or Backbone or all those little frameworks around, what was your thinking to say, well, those guys don't fulfill what we need?
Yeah, the main things that we investigated first were Angular. Knockout.js was another thing at the time.
Oh yeah, Knockout.
And then we made weird hybrids of them, and one of them involved like making Jekyll, like generating static sites and then adding Knockout to it after they were loaded, all kinds of crazy things. And but the problem with all of those was that we decided that we needed a program that ran in the client, which is something that's obvious to us today. Like I think everybody kind of agrees on that like maintaining state in sessions and redirects with URLs and stuff like that is just not, you can't form abstractions there. Like that makes all your abstractions leak by necessity. So you needed to have the things that make abstractions work are first class representations of things, meaning like that anything you have, you can make an anonymous version of it. So those are things that you can't do when you're storing stuff in sessions, you know what I mean? Like when you have to hydrate and deserialize and so on in order to build up the state for every request. So we decided that we needed something that ran purely in the client, and we decided on a Lisp, and we initially had our own crazy, HLisp was actually its own Lisp because ClojureScript didn't really exist.
Yeah.
It was pretty crazy. And not great. So thank God for Dave Nolan and Rich and ClojureScript.
Yeah. So you actually had it even before ClojureScript, in fact.
Yeah.
Wow, I didn't know that.
It was pretty not great. But we had F expressions and stuff. Like basically, we just like spent all our time like playing around in like, 1950s Lisp technology.
Right. Okay. So you're writing your own evaluators.
Yeah.
Like that.
Yeah. It's pretty sweet.
Okay.
Got paid to do it, kind of. But yeah,
they didn't know, but you got paid.
It's a nice thought experiment.
Right. Yeah, I mean, it was an actual experiment too, unfortunately, but...
Yeah, that's true, yeah. So I think you should have left it at... Do you think you should have left it at the thought level instead of implementing it? Or what were the insights that you got from doing this one? Apart from, hey, let's not do that again.
From making the Lisp? Yeah, it was... I mean, I think we just learned a lot. I learned a lot about how Lisp works, making it and then optimizing it and stuff. And, and also what we needed from Hoplon, because it was basically implementing a lot of the Hoplon stuff in kind of...
Behind the scenes, Hoplon uses jQuery, right? Or does it?
Well, anything that works on the web today needs to use some kind of DOM standardization interface. And we picked jQuery just because, it has like 75%, like 70% of all the websites in the world have jQuery running on them, versus like for the Google Clojure library, it's like 0.0005%.
Yeah, that's true.
And so we started running into bugs there, and I just had zero inclination or bandwidth for fixing like cross-browser bugs. And jQuery is 34K,
Yeah.
And so
well, so I guess that most people have already got jQuery as well on their PC or their phone or whatever, because if you CDN it, everyone's got it from their other website visits.
Yeah, I mean, also like another thing that's important, I guess, to note is that like our interest is in making business applications. So we want to make, like what I want to be able to do is concentrate on the functionality of the back end and have the front end be as straightforward and simple as possible. And I just want to make business interfaces for applications that people are making money with. So a lot of the things that you would get from like we're not implementing, Instagram, or things like that, or like Twitter, like show somebody some tweets. Like we're implementing workflows and things like that, which is like an important consideration, because stuff like load time, loading an extra 34K of stuff is not a problem for these people, because, like Gmail, you keep it open for a long time.
Yeah. So I remember, before the show you were discussing about web components, and you mentioned that one of the things that you played with before was the web Phew thing, right? So can you give us some idea about what your opinion on the web components and how it fits into Hoplon and the web Phew, of course?
I mean, web Phew is a kind of different thing. It's sort of like the pre-React React.
Yeah.
It wasn't so much about, it didn't have like such a, well, maybe I just didn't know, but I didn't see like a very pervasive component story. He was more interested in, sort of the React, the virtual DOM experimentation, which was super cool. I remember seeing it at the conj and, thinking, good job, dude. Very nice. But like the main thing with Hoplon, the thing that we really wanted to accomplish is to have a very, very strong component story so that you can make building blocks. So like the way I see a user interface for a business application especially is you have you make a toolkit of components, and then you assemble those into an application. Where the application itself is just an assembly, kind of like, like what we did with boot. When you make a boot script, you're just assembling tasks that are, decoupled from each other.
Yeah.
You assemble them into a thing.
Yeah, but this has been done multiple times, right? People have been trying to achieve this holy grail of getting web components, right? Back in the days with the Flash RIA things, and then, of course, Java saying, yes, you can build the whole applet stuff, and then you don't need to worry about the DOM at all. And the DOM became like a very least common denominator. So it's very difficult to get components that people can share easily with each other. So what do you think about that?
Yeah, so the reason why we arrived at Hoplon is because we determined, in our opinion, that the issue with all those attempts were that they make a fake DOM. So you're not actually operating on DOM elements themselves. And so there's this impedance that causes your abstractions to start to leak. You have to start making all kinds of special case arguments and stuff.
Yeah.
And so what we wanted to do was take, so we looked at HTML, and HTML is a programming language already. It's just a very poor one. It doesn't have any means of abstraction, So, but it does get parsed, and it gets parsed into an abstract syntax tree, which then gets evaluated, which becomes a document object model, where things become objects. And so we realized that with Clojure, all we needed to do was add, an invocable, add IFN implementation to make DOM elements themselves invocable, and we could achieve the goals of web components in a lot of ways.
Well, everyone says, don't they, that XML is a kind of poor man's Lisp, and so HTML is a form of XML. So yeah, you're right. When you squint, it makes sense that you can take that each of the DOM elements and essentially treat them as an S expression.
I think I would say it's more like a sadomasochistic version of Lisp. I mean, it's not actually a poor man's Lisp. The sharp angle, the sharp brackets actually they pierce into your eyes. So, on the other hand,
at this other startup I was working at recently,
that's bracketist. You do know that, don't you?
Yeah, I was working at this other startup where we had to parse tons of crazy XML SOAP stuff from the travel, the OTA. There's this travel thing, and it's enormously enterprisey and everything. And so I was working on this library that I called XML SVU, which was making it invocable. It wasn't a complete success because I kind of ran out of steam, but.
Okay, so Hoplon is essentially the UI level thing that you use to build the front end, and there is this always a discussion about every time when people make a web framework, they keep comparing that, hey, we want to make it friendly to the designers so they can write HTML. So if you see most of the newer applications, they try as much as possible to make the front end very HTML-like. So what is the story in Hoplon for that? So designers can write HTML or?
Yeah, we started out with that because that was basically where we were at business-wise. In other words, the Fresh Diet, they needed a thing that they could put designers on, and it needed to work well with them. So that was something that just fell out of the design of it. We could evaluate HTML. In other words, HTML can be transformed into S expressions. So we did that, but now we've kind of moved away from that to a more an even more utilitarian view, which is that we don't need to have, at the Fresh Diet, the marketing department had a huge say in how things worked. But at AdZerk, say, we're dealing with, it's business to business. We're dealing with professionals. So utilitarian is the most important thing. So we're not really that interested in, making everything ultimately pretty. Although Hoplon can still do it, but that's not where we're kind of focusing ourselves.
So you imagine that developers are mostly users or developers rather than designers, in other words.
Right,
And so you're thinking bootstrap-tastic and enable the developers to make the most straightforward UIs to get the data in and get it out and get it represented, rather than the kind of beautifully pixel perfect finessed UIs that maybe iOS apps might dream of.
Right. I mean, like at AdZerk for our application, we have an excellent designer who made us. He based it on Bootstrap, but he could have done anything. But he made us a UI kit, and we just used that. And so he gave it to us as HTML, and we transformed it into components. And
okay. So before we move on to the next topic, I'd just like to ask you one question. So how independent is this? So can I use just Hoplon UI with any of the frameworks that I can play with, or is it very tied to the two other pillars like Javelin and Castra?
No, they're all just libraries. So
okay.
Yeah, you can just from any ClojureScript application, you can just pull in the Hoplon dependency, require the namespace, and use it.
Oh, okay. That's sweet. Okay, let's talk about Javelin then.
Just before we move on to that, just one quick final question. Sure. Since it's in final questions mode, is how well does it play with the Bootstrap ClojureScript stuff? Is it just all drops in, or is there anything special?
You mean like ClojureScript and ClojureScript?
Yeah.
That's something I'm definitely want to look into it, because I'd really like to have eval for like the spreadsheet aspect. Would be really nice. I just haven't had time to figure out like how macros exactly work in that environment, but yeah, I'm also curious. I don't know if you guys know, but I'm curious about, could you compile ClojureScript and ClojureScript and then run it through the Google Clojure compiler, like instead of using the Clojure compiler?
Yeah. Yeah. I think right. The clips thing is basically that, right? You write ClojureScript and then it's going to compile using ClojureScript. But I'm not sure whether it is using the Google Clojure compiler there. I don't know. Maybe we need to look it up. But I'm sure plenty of our audiences will be happy to let us know. Hey, you're wrong.
One to follow up then, that one. One to follow up.
Yeah, that's definitely something I plan on experimenting with. So, because I really do want to have like in client access to eval too.
Yeah.
Yeah, to make it more dynamic, and so you can embed Hoplon in other kind of environments. Yeah. Okay. Good. Okay. Cool. I didn't know if there was going to be anything special required there to make that happen, but I guess not. But it will just be more about exploiting the capabilities that environment offers.
Yeah, we'd have to rewrite some macros to be cross-platform,
Right. Okay. Yeah.
So how difficult is it to get into Hoplon's code? So what do you think? I mean, if people want to contribute, or people want to, what are the open-ended things that we can get into? Do you think is there contributing more components, or how what is the entry point?
Well, so there's a few projects going on. One of them that's really interesting is this guy Jumblurg on Slack. He's making a really interesting UI component library on top of Hoplon, which is really like what we want. That was our goal, is to end up with these kinds of things. So that's had like a bunch of activity. So there's a number of contributors and commits every day. It's still kind of like alpha, but that's like, yeah, that's totally what we want to achieve. So all kinds of things like that. Hoplon itself is really, really simple.
Yeah.
So, we're making some changes now, getting ready for a new major version. So we're deprecating some things, but there's not really that much to it. So there's no real roadmap for it. You know what I mean? Like,
yeah,
there are some problems that need to be solved.
As you said, you just made something that is going to last forever. So that is going to make you more productive over the period. So I think it's pretty stable right now.
Yeah.
Yeah, I guess the other thing I was just going to ask you about, Micha, just quickly, is all these other functions, like we mentioned jQuery and stuff like that. How does it play with like CSS frameworks or other JavaScript frameworks?
Hoplon only uses jQuery for very, very small number of things, like specifically dealing with attributes, which we found was buggy in like Google Clojure library, things like that. Because attributes, as we know, are not always properties of the element. They need to be special cased for different, user agents and so on. So that's the one place that Hoplon core uses it. And then Hoplon has a concept of custom attributes, which are like attributes that you can define how they behave as a multi-method. So every element, so you could have like a fade in attribute, right? That when you turn it to true, the element fades into visibility. Or if you set it to false, it fades out, right? And that attribute can be applied to any element. And so a lot of the default implementations, the default attributes that come with Hoplon are implemented using jQuery. But we're planning to separate that out into a separate namespace, so it'll be like the jQuery dependency will be optional.
Right, okay. So you could potentially use other little frameworks like Zip or something like that. Yeah. But okay, so that's like in your core. But what about if I want to use, I don't know, some other like like let's say I want to use a CSS library like less or something like that, or if I know there are like CSS modules now that you can bring in that are JavaScript modules. How would we do that in Hoplon?
Hoplon doesn't have anything to do with that. You can just use them, and most of the time you can just use jQuery plugins directly because you're dealing directly with the DOM. There's no complication of making it compatible with the DOM.
Now, what I mean is, like, let's say you've got a table called Phew, but that table, the name of that table is Phew inside of a Hoplon page. Is that still called Phew as far as the CSS is concerned? The selectors can still use the name Phew?
If you set the class, sure. Or the ID or whatever.
Yeah, okay.
Yeah, I mean, they're just regular DOM elements. Hoplon doesn't...
Okay, so it's not name mangling or anything like that. You don't have to... There's no special ceremony to introduce like all of these things on top of Hoplon. It just all plays. It's just all plain vanilla stuff. You don't do any mangling or name changing underneath the covers.
Not at all. Yeah.
All right. Okay.
Yeah, that's one of the thing. That's the thing that Hoplon does. It allows you to program with the actual DOM. So there's no magic or funny business going on at all.
Right. Okay. So when you look at it on the browser tools and all these kind of things, it's just looking like straightforward DOM elements.
Yep. Except for IE8. IE8 has like a weird... You'll see some weird things in IE8, but it does actually work. We have tests and everything. So.
Well, you said business applications, so IE8 is like the standard thing for probably, I don't know. we have moved on. So we have moved on from IE8, luckily, at least in the work that I'm doing.
I think most business applications have moved on from IE8 as well. The business applications are all using more modern environments. It's worse for consumer environments where, the consumers out there are, 20% of them or something, or 15%. And it's always diminishing year by year, but there's still probably 20% that if you want to reach 100% of all users, you have to include IE8. 97% plus. Anyway.
Luckily, AdZerk doesn't care about IE8, so.
Yeah.
Well, do you have a shim or something, or do you have some special code to deal with IE8?
No, we wrote it. We special case some things. But I guess so. Our thinking is that if you're making something that works in IE8 and works in a modern browser, you're going to have your own special cases too.
Yeah.
So. True.
Yeah. I mean, jQuery helps you as well.
Absolutely,
I guess. Yeah. All right. Cool. Right, so we're just so anything else you want to talk about with Hoplon before we move on to the next pillar?
Nope.
No? Okay, awesome. All right, that's good. So the next one we wanted to talk about was still really kind of like let's say the jazzy stuff in the Hoplon ecosystem is this Javelin spreadsheet, functional reactive programming model that you have, because everyone's crazy for FRP on the client side now. No one knows what the fuck it means, but everyone wants it, and especially since, and again, I don't think people know that React says it's a one pure function of rendering, whatever that means. But I think people feel somehow that FRP is the hotness. Obviously, Elm has helped to make that the hotness in San Francisco, but where are you coming from in terms of like FRP and spreadsheet models for Javelin? Because I know that's something that you're excited about in this framework.
Yeah, we've been like kind of fascinated with spreadsheets for a long time, and we made applications with Angular and with Knockout, so we had some experience with like some observable type situations, and then we just like went in and we found this paper for this library called Flapjacks. So I think it was a Microsoft research project.
Yeah, I think that was very long time ago, right? It's a Lisp thingy. Yeah. I remember subscribing to their mailing list. That was pretty amazing, by the way.
Yeah, they were like schemers, and they wrote their JavaScript in a really weird schemy way, which is pretty awesome.
That's true.
Like all their curly braces were like end up on the same line or something.
Exactly.
But,
so they were really kind of working on this principle that JavaScript is a form of scheme.
Yes.
I think so. Yeah. But it didn't have enough support, by the way. I think it was a long time ago, somewhere in the 10, 15 years ago, maybe. Anyway, that's
I mean, the crucial thing that we got from that was the dependency graph and how that, the concept of like glitch elimination, they call it glitches. And so like we had this thing that we were already working on called declarify.js or something like that, which allowed you to like make a spreadsheet basically, but using attributes declaratively, whatever. It's kind of confused. But what it did was it did dirty checking. So like in FRP, there's these two kind of competing things, and one of them is dirty checking, and the other one is like dependency graphs. And with dirty checking, that's very similar to like what React does, is you evaluate everything, and you detect what changes when it's time to make side effects, right? And so like with a spreadsheet, what you might do is you might just evaluate every cell, every formula, you know, from left to right, top to bottom, and you keep doing it iteratively, like the way Clojure expands macros, until it stops changing. And then you know you're there. And but this doesn't work very well like when you're making an application, because like you might get the right values in the formulas, but a lot of times you need those values to schedule side effects, which are the thing that really matters. Like launching the nukes, you need to do that right. And so what we would end up with is we came up with like this test called the...
I don't think there is a right way to launch the nukes. I mean...
Well, doing it only once is a start, right?
Yeah.
Oh my God.
Yeah. But speaking of the whole spreadsheet model, so what is behind it? Because I know, so Javelin is basically a ClojureScript library, right? So what do you use in behind? I mean, do you have an atom with watchers and how does it actually work?
Yeah, so the atom with watchers, you end up with glitches, which is when things happen out of order and they, for a certain amount of time, have the wrong value, you know? So the way we eliminated that was by making a new reference type. So in Javelin, cells are first-class objects, meaning you don't need any macros to work with them. So we have a bunch of macros, but that's just, you know, syntax. The macros just expand to function calls. And so we made a new reference type, and in Clojure, a reference type is, you know, a thing that has like some semantic for updating it. It contains a mutable thing, but it itself is immutable, and you can watch it. And so we implemented that. And the unique property that Javelin cells have are that they respect the dependency graph. So if a formula depends on cells, it will never update until all of the cells that it knows about have already updated. So in effect, it's like storing all your stuff in one big atom. In other words, you get the same atomic view of the world, because any given part, the view of its world is that it's the last one to update.
Okay. And so how about the local state? So I know that there is, when Ohm came in, you know, we wanted to keep the entire application state in one atom. And there has been some discussion around how to keep the local state, like the form validations and these kind of things. Because then you're essentially putting everything onto the global application state where you want to have a temporary state. And that made the whole tree very unwieldy, especially if you have multiple forms. And so how does this work in Javelin then? Or in the Hoplon world?
So with Hoplon, you have a real reference type. So you can make anonymous cells. You can, you know, all these things are possible. So you just use regular Lisp. So you use the scope mechanisms that are the foundation of Lisp. So you could use lexical, global, dynamic scope, whatever you want. And that's how we organize it, rather than needing to make cursors and things like that. And the problem with cursors is that essentially like when you have the big atom approach, you've essentially recreated the concept of namespaces, but like in a poor man's way, when we have real namespaces. And where you would run into problems there is with things that need to be anonymous, because like how do you make an anonymous thing in a map? You have to gensim something maybe, I don't know.
So just to clarify a little bit on that then, so what you're saying is your one big atom is mostly for this like dependency network, but it's not for everything in the application.
Well, I think all the things, it forms, it emerges. The units of atomicness or whatever are emergent, meaning like you set that up. So you can have as many input cells as you want, and these are basically the places that you can call swap on. And then there's formulas that are dependent on those, you know, derived state. And so like an input, you know, a number of input cells plus all the things that depend on them, that forms like one atomic unit that's sort of like a big atom, but that you don't need to have a map and address things via keys in the map. You can just use vars and address things by evaluating their symbol.
Okay, so you're always referring to the thing that is being updated, like the value that you see in front of you rather than some side thing.
Yeah, and you're not looking things up in a database. You're operating on first-class objects rather than proxying that object into this giant database.
Yeah. So how does remember when OM was announced, and one of the biggest things that David Nolan pointed out is that you can actually do undo and redo sort of thing. So you can actually go back in the state. So does it translate similar on Hoplon as well, or?
Well, okay, so I have two things. First of all, yeah, you can do that in Hoplon. Like we have a tic-tac-toe game that implements undo in one line, because you just have a vector of states. So every time the state changes, it puts it there, and you can pop it and push it. And there's a cell. So the state is a formula cell, which is just the first item in this, in this stack. But however, I should say though that like in my actual work, all this stuff is useless because, I'm making business applications that have workflows, and people's money is actually, we are actually launching nukes all the time, those nukes being people's money. And so like you launch a nuke and then you press undo and the UI rewinds to the state before you launch the nuke. Moscow is still getting torched. It's not helping you. And the fundamental problem I think is that the state of the user's brain and understanding does not rewind when you press a button. So I think at the end of the day, you're always going to need a situation that's more like Git, where you make a reverting commit. And you always need, like when you change your password, right? A thing comes up saying your password was changed successfully. What happens when you undo that?
Yeah, and I think that one of the things when I saw the undo things, I completely agree with you. I mean, undo is basically like the user level things. I mean, okay, I typed something, I just want to undo, and it's not useful for applications where, as you say, everything is backed up by a business process. But it's useful for if I'm doing a document editing or something like Photoshop. You have this undo history where you can actually go back to the things. But there, I think it's also I remember when Photoshop first came in, and the initial versions, they also have the limit, like you have like 7 or 10 things, and then you could only undo for 5 or 10, and then every time I had to remember that, oh shit, I need to reset the number somehow. And then they introduced another thing called snapshots. So every time you can have a snapshot, because it can become very unwieldy because you keep adding this state again and again and again, and you obviously don't want to go back to the original. So that kind of stupid.
Yeah, but that was a bit weird though, wasn't it? Because in those environments, you had to put so much on the stack. It was probably hellish, Whereas obviously it's a much lighter weight in Clojure. The only thing that's like the problem, I guess, is that there's two parts. I mean, obviously the example people give is like the drawing applications, like you say, and that's the demo that David Nolan gives, for instance, is the drawing app where you can undo things, and that's not a business app. I get that. But the other thing is that, like on a form, say if we're undoing form entry, which is another interesting example, is like let's say you have a form that has 10 fields. You've really got a choice of either undo per. If you're typing something in a field like a text field, the browser supports undo in that environment. But if you've put something in one field, then put something in the next field, then put something in the next field, the only way the browser will support undo across all of those fields is by pressing the cancel button. So I guess there are small use cases where you might want to undo one or more of those inputs. But I don't know. It's definitely an edge case. It's edge case, and it's
trivial
doable
to implement
anyway.
In Hoplon, just as it is in any ClojureScript application that.
Because you're basically just saying, look, I just want to maintain the state of this thing somewhere, so just pop it onto a vector, and off we go.
Yeah, that's what we do in like the tic-tac-toe game,
Yeah. Okay, right. So you in the spreadsheet model, there are formulas for each cells, and then a cell can update the other cell, or a formula in a cell can update the other cell. And so how do you handle the dependency between them? If I have a cell A1, for example, to speak in Excel parlance, so you have A1 and then you have B1, and then the formula in B1 actually updates A1, and then so it's basically a circular dependency. So how do you avoid that one?
Yeah, that never really comes up. I mean, you can't do that in spreadsheets, in most spreadsheets either, you know? But usually you don't want to program that way. So that's one of the big things. Like Javelin isn't really FRP. Like when we first released it, we wrote FRP because that was the word. And like we had done all this research and we had read all these papers and all of them were like FRP. But then we didn't use all this FRP stuff. Like most of the time these FRP papers would end up like, how do you do Fibonacci in FRP? But like we don't want to do any of that. So Javelin is the layer for piping information, flowing state around. So it's like a data flow is what we call it now. And so the idea is that all of your actual work happens in functions or whatever, and you can separate those out, you know, and it's just the flow of state.
One small example, I think, that I saw in the early days from the FRP crowd, because I think the FRP crowd are also interested in all the signals and events and merging, all those kind of things. So there's a bit of there's two parts to it. One part is like the spreadsheet bit, which says if I change the value in A1, you can tell that VJ is doing an MBA now because he's so such an Excel guru. You know? But you update the cell in A1, so that means that the value in A1 is changed. So the formula in B1, which is like a calculation 10 times that value, that gets updated automatically, and that's all great. So that works in Javelin. The classic FRP example, I think, is where you're looking for a username in a database. So you start typing out the username, and then letter by letter, you start to
stream
look back on the server and see which names are available. So do you have that kind of feature as well, where you can like treat all the inputs as signals, or is that the bits that you're not really implementing?
Well, like the terminology that we're most familiar with is behaviors and event streams. So I can never remember which one is the signal and which one isn't. But anyway, behaviors are things that always have a value and you could look at them at any time. And event streams are things that have instantaneous values. And we decided that we didn't want event streams at all. Like we had no use for them. They weren't helpful in the conceptual model in any way. Because if something doesn't have a value at all times, that means that you have to have a callback to catch the thing, and that now the order that those things happen in is important. Whereas with behaviors, the dependency determines the order, so it's not even something that's under your control. And the fact that it always has a value means that you can use all the things that reference types are good for to relate to. So you could dereference it at any time, things like that. And if you need something that acts like an event stream, all you need to do is make a vector that contains one unique object, like a UUID, along with the payload. So for example, because one of the properties of Javelin is that it will only reevaluate formulas when their inputs, like when their dependent cells, the cells they depend on, they change their values. So that was a thing that didn't exist in any of the other FRP things that were out there, like flapjacks or whatever, because they all use JavaScript and there's no like equality story for JavaScript. And that like polluted the entire thing from top to bottom.
So super inefficient, where you have to check everything from top to bottom.
Yeah, and also it's crucial though. Like this once-only semantic is extremely important in order to be able to build robust programs. Like even if, it's not even about efficiency. It's about where you attach the side effects.
Correctness, yeah.
Yeah, because this will ensure that like the nukes are only launched once.
Yeah. So before...
Maybe we should just leave the nukes out of this.
I'm American. That's all we have.
Yeah, I know you're an American, but you're frightening us now, Micha.
So before
why can't we launch koala
We're nice,
bears?
peaceful Europeans.
Yeah, launch koala bears.
Eh?
Yeah, or kittens and
okay, we're launching the koala bears. That's the kittens.
Kill the kittens or whatever.
That's
I don't know. I don't know if there are any cat aficionados in the
no.
audiences. Please don't scream right now.
Look, we're a vegetarian podcast.
Exactly.
DJ,
So
we just launched the vegetables.
We may kill cats, but we don't eat them. That's what. That's the idea. But,
we don't kill them either. Okay, it's not happening.
Let's all live together in harmony with cats.
No kittens were killed to produce this podcast. Let's just be clear about
that. So before we move on to the next topic, so do you see any reason to use or port Javelin into Clojure world? I mean, on JVM level things.
You know, it's interesting. I haven't found any. So there was recently a request to add to Javelin like a lazy evaluation semantic, meaning that the formulas wouldn't update unless there was a watch on it or something like that. And so like to me, that's like the kind of the world that you have on the server, because you don't want to have a million things out there updating all the time. Like you can't afford that on a server that's heavily loaded. And what you end up with is like, if you don't dereference it, it doesn't compute it, right? But that's just calling a function. I mean, if you need to, if dereferencing the thing produces the value, you have just effectively called a function. And that's where I always end up back at. Like we do have a Javelin port for Clojure. And I think the only place that it would be useful for me would be if I was making like a Java UI. Because in the UI, you really do have like persistent things that need to reactively update. But on a server, you can't afford that.
Yeah, I mean, my question was related to whether we can build desktop applications. Well, not with Electron and all the crap. I know everybody wants to write Electron these days and then bring JavaScript onto the desktop. But I was thinking, can we use Javelin as a backend or the model layer for Swing applications or JavaFX or something like that? But yeah, I mean, it makes sense. I mean, as you're pointing out, it's basically a function because you just want to call it and then get it updated.
But for UIs, it totally makes sense.
Yeah. Not on the server though.
But maybe the other part of the server story is where you want to do some rendering on the server side, just to render out the UI at least. But I guess that's less Javelin-y and more Hoplon-y.
Yeah, and it's also of like,
if that makes sense,
it's of limited utility, because we do have you can pre-render Hoplon, and it loads your thing in a Phantom.js or whatever.
Yeah.
So that's good for SEO, for example. So you can do like the Google, crawler thing.
Yeah.
And it's good for like when the page first loads. So like have a splash screen or something. But in general, like you really want to be working, like you're making a program. And it's not like, like imagine on a desktop, like a normal program, you don't want to have like this pre-computed stuff that needs to be torn down, and you want to like do your computing as directly as possible because.
Yeah. Okay. So
just one final thing on the Javelin thing we didn't discuss actually, and then we're running a little bit late, but who cares? It's all great stuff. Is the ability to use these lenses, so you can have like much more, because I think like the concept of having like a function, it's some sort of formula cell where you say this function is equal to that function. You also have these lenses. Can you talk about that a little bit, just to kind of show that you have, let's say, more arbitrarily complex features in Javelin than we might think, just from a pure, simple spreadsheet model?
Sure, yeah, and lenses, the term, maybe is not entirely correct, but but basically
the Haskellers are going to get upset,
exactly,
are they?
Yeah. I don't know which flavor of monoid it is, but so in Javelin, like in a normal spreadsheet, you have input cells and formula cells. And the contract there is that an input cell can have any value you want, and at any time of the day or night, you can put a new value in there, and you can get the value out whenever you want. And the contract with the formula cell is that there is a constraint on the value of this that will be in this cell, and that constraint is expressed in terms of other cells and constants or whatever values you want. But the idea is that this is a rigid constraint, and you can guarantee that at no time will you be able to observe this guy in a state that is not consistent with this constraint. So if A is 1...
So it's like an acid style thing almost.
Yeah, so if A is 1 and B is 2 and C is the formula A plus B, that thing will definitely have 3 in it. You'll never find it in some other state. So that means that like calling swap or reset on the formula cell makes no sense whatsoever and should cause an error, which it does. So, but what we implemented is like a very general form of lenses. And the idea is that when you can give a request to the formula to update. Say, I would like you to make your value this. And maybe that formula has some implementation that you've given to it that can update the relevant input cells to make it so. So that's the Javelin form of a lens, which is, so you can create a lens from a formula expression plus a callback.
Okay.
So the formula expression is what the value will always be. That's like a solid constraint. The callback is something that attempts to update things in the world such that it will achieve the result that you want. But it might not actually work that way.
Do you have a kind of concrete example of that?
So one place where we use lenses all the time is, suppose I have a component that is going to, say, accept like a form component, right? That has maybe your name and your email address or something. And maybe if the person already exists in the database, you want to pre-populate it with the current values. And you want to have constraints on what those values might be so you don't let them type in something bad. And you want that to come from outside of the component. So you don't want the component to need to know about how that works. So it would be great if you could pass them a cell that will that has a constraint on which values it can ever contain, and might have a default thing, but that you could also call swap on it to try and set the value, right?
Okay.
So that's like a use case. So you pass it, you construct this formula, which is saying the formula would be like, look in the database, would be like the default value. And this callback would be able to do validation and stuff like that, and then it would go into the mutable thing, the input cell, and update that such that the name in the form input would actually update. Super useful.
Okay. Actually, that's really cool because someone asked me about that at this Clojure meetup, and I'd forgotten how it worked. So now you've given me a great answer. So yes.
That guy.
Jan, I think he was called. Yeah. What he said.
But that's one of the things that I'm kind of like, I don't know, one of the things that I enjoy that came out of it was like how simple the lens implementation and like how general it ended up being. It really just kind of makes me happy.
Yeah, because actually it's quite interesting that that part of it is definitely something which you don't see anywhere else.
Yeah.
That aspect of that, do something to me, do something outside of the scope. You said it better. Okay.
But we get it. I mean, we can do something to you. That's what you mean.
Yeah, it's like, here's a request to do something, and then your internal implementation might make it happen or might not. Does the best it can.
Okay.
Yeah, so you've got a loop, basically, that's optional. It might or might not result in a change.
Okay.
Yeah, that's really cool. Yeah, great stuff.
We looked at the UI, which is Hoplon, and the Javelin that you use on the client side to store the state and make sure that that reflects the thing. And of course, the other piece of the puzzle is talking to the backend, right? I mean, how do you send this data over to the server? Because obviously you need something in the backend that's interacting with the database or managing all these things. So you have the Castra library for it, right? Can you give us a quick overview of what Castra is and how does it fit into the three-pillar thing?
Yeah, so Castra is, I don't know, the buzzwords would be like RPC, CQRS, those types of things. And the idea of it is that in the client, you can call a function that gets evaluated on the server. And this function is for side effects only. And so when you call the function, it doesn't return data, doesn't return a result. The result ends up in a Javelin cell. And how it factors into, how it relates to CQRS is, with CQRS, you have like a separation between command and query. So I send a command to the backend to, change my password, say. And actually, that's a bad example, but to change my birthday, And then the query is, what is my birthday, or what is my user information that might contain my birthday? And decoupling the two things gives a lot of benefits in how you can organize the front end, because take, for example, a login form, right? Basically any interaction with the back end, you normally have two concerns that are at odds with each other. When you log in, when you fill in the login form and it talks to the back end and you've successfully given your password, that login form doesn't know anything about what the application needs to do once you're logged in, nor should it. It should only know about, how to get you logged in, and that's it, right? So you have that concern. But also, like, suppose your password isn't correct. It needs to show you an error message or something. So it needs to know about how to deal with errors locally, but it needs to know, but it shouldn't know anything about how to deal with like successful state changes, because those changes are at a totally different level of your application. And so what we do is when you call one of these RPC stubs on the client, it returns a promise, which will when the promise is fulfilled, it contains information about the status of the request, meaning like if there were errors, it returns them, validation errors, connection or whatever. But additionally, when the AJAX request actually completes, rather than returning the result to the caller, meaning like this query, it gets put into a cell.
Okay.
And that cell.
If I have a big form that are basically, I'm thinking about a business application, right? So I'm filling in data to book a flight or something. Doesn't matter, something like that. So I'm adding all this information and I'm clicking on okay, send this data back to the server, and I have another view where it shows a number of flight reservations. So that needs to be updated when the server gets the successful reservation, for example. So is it like what is the sequence of events there? Is it an optimistic update that locally it changes, or is it actually going back to the server and then only the cell gets updated if the backend is successful? And how does the error handling work in that case?
Usually it's a combination of those two approaches, depending on how your application is organized. Because I could see there being two stem cells, we call it.
Yeah.
Like one of them showing all the flights that you care about, maybe.
Yeah. Yeah.
And it's probably going to be paginated, so maybe the current page.
Yeah.
So there's that, and there's also like the purchasing workflow. So maybe you have information about the current, like your current place in the workflow, and so there might be like a bunch of different steps in this workflow to book a flight, and so those would be a bunch of RPC calls probably that all are related to the same query, meaning this query is what's my current workflow state.
Yeah.
And so every time you make an RPC call, that does some stuff in the back end for side effects only, and then the same query function is run, and that value gets put into the cell, right?
Okay. So the RPC's got two parts then. It's got like this, essentially this part where normally with an RPC, one expects the RPC to take a call and then return a result. But what you're saying is this one takes a command and then you tell it where the result is going to end up in some cell somewhere. And then you can evaluate that cell how you wish.
Yeah, and it's not even, I don't really think of it as a result because, so you might have let's say you have 5 RPC functions that implement this workflow. There would be one single query function that is returned for every single one of those. Meaning the client, when that AJAX call completes, it gets the result of evaluating the query expression, not the RPC expression.
Okay.
So how are the two things linked together then?
Well, decoupling them is huge because you have, so like for this workflow thing, there's a query on your database that will return all the information about the state of that workflow, right? And that's completely decoupled from the things that are performing side effects mutating the database, which is very powerful. So in Castra, when you define your RPC functions on the back end, they're like, how in Clojure you can make preconditions and postconditions?
Yeah, yeah.
So we extended that so you can make a query condition, which specifies the expression, the query expression, to return to the client.
Okay.
And you can also have preconditions, which are performed kind of like Clojure preconditions, but only when it's an HTTP endpoint. Meaning that if one RPC function on the back end calls another, it doesn't evaluate those. So you don't need to mock any state or anything.
Ah, okay. I didn't get that either, but okay. I'd written one of those. I'd actually written one of those, and someone asked me what the difference between the normal pre and the Castra pre was, and I couldn't for the life of me remember. But okay, that's good to know. Yeah, so it's only when The HTTP endpoint is called.
Well, it also
okay,
has like
cool.
a crucial other purpose. Separating that out is that you could, if you send validation metadata saying like operate in validation mode, it only performs the preconditions but never the body. And this.
Right.
Yeah.
Okay.
So like what we do at AdZerk.
A bit like a fancy head.
Exactly. Yeah. And like at AdZerk, what we do a lot, like for pretty much every form, is we have, once you submit the form, you're like while you type, it's validating everything. And we validate on the back end mostly. Like we have very little front end validation because it's like it's so solid to do it this way that it just like, we get like, it's really effective for simplifying how your code works.
So what is it piggybacking on? So Castra uses a ring or what is the backend based on?
Yeah, it's implemented as a ring middleware. So
okay, so we just need to just add the library and then start writing RPC functions, and then we can call them from this one. Okay. So another question that I was interested in is the whole server push thing. So how can you do that, or do you think it's a good idea or not? Server push stuff.
Yeah, you can do it. Like my needs, for the type of business applications I write, we have very little use for that. Most of the applications we write doesn't have a lot of interaction between users.
Yeah.
So in that situation, polling makes a lot more sense. Because it should be possible to do it, of course.
So do you think what is the best use cases? I mean, of course, every framework can be used or abused to fit into every kind of application that you can build. But do you think Hoplon is something that you want to pick up if you want to build, for example, something like Slack? Lots of users, lots of clients, and.
I think Slack would be a good. Because that's like basically any application that you open and you use and you have workflows. You know, if you expect that all your customers are going to be there for less than 30 seconds, and you expect to make your living that way, don't pick Hoplon,
Yeah. So better applications, and then heavy, or not heavy, but rich applications. And before we close on Castra, I just want to ask one more thing. Like, so how does especially when you're building these rich internet applications, using or rich RIAs or whatever, or sparse or single page applications, the one of the questions that keeps coming back is about the sessions and maintaining the session on the server and logging out and these kind of things. So how does that work in Hoplon?
So usually the way we organize the applications for deployment is we'll deploy the front end, the Hoplon part, all to a CDN, because you just end up with HTML file and some JavaScript and whatever. So we put that on a CDN, and then we use cores to talk to the Castra backend, which is just a RPC, like just a HTTP endpoint. So cores makes things a little bit difficult sometimes, like with cookies and whatnot.
Yeah.
So we have another implementation that, like, I just needed to ship a thing, and I had so many problems with cores in different browsers that I made a local storage-based implementation.
Okay.
But the general approach is you just have an identifier that you don't need to store a lot of information in the session. You just need to store, basically the identity of the user. That's the only thing that needs to persist. We encrypt it, send it over to the client, store it on the client. They send it back with every request, along with like the CSRF tokens and whatnot that are automatically generated by Castra.
Yeah.
It just sends an additional,
All right.
So
thing.
Because Castra is based on Ring, I can use all sorts of Ring middleware on it, right? Any kind of middleware that I want to put in. Or do you think there is anything that you should be aware of or careful about?
No, not at all. And in fact, Castra doesn't care about URIs at all. It'll accept any post. It just cares about the body because it's an RPC call.
Yeah.
So you can mount it anywhere.
What we do with that kind of thing, by the way, is we often use a CDN, but we subdomain the CDN onto our own domain. So it looks like, from a course perspective, that you're on the same domain. So if you with CloudFront, that kind of thing, you can make your bucket as a subdomain of your domain rather than having all this course crap, because course seems like hell. Well, it doesn't seem like a hell. It is a total hell. You know, it's like, it's just ridiculous. Especially for, it's fine for when you really have to trust something, but mostly it's just an impediment to good deployment practices as far as I can tell. Rant over. Okay. Bam. Right, so the other thing was what we were talking about was the actual, I think this is something which comes up a lot with the modern applications, is this, how do you transfer like payloads? Because is your payload like a REST payload and you have to go to 10 different servers to get this payload, or does the RPC give you a nice Clojure or ClojureScript payload that you can rehydrate easily on both sides?
Yeah, that's the key. One of the most key aspects of Castra is that when you call the function in the client, it's as if you were calling a Clojure function. There's no, you give it Clojure data, and what ends up in the cell is Clojure data. And you can do the same thing in the REPL in Clojure when you're working and testing and all of that. So it's essentially just like a function call.
Okay, so you can get back any kind of collection or data structure or whatever you want.
And you can, it uses transit in the middle, so if you want to extend that, you can send record types over, whatever you want.
Right. We've discussed that in the reader program, which I'm sure you've listened to many times, Micha, by now. So just refer back to the reader episode, everyone. Okay, that's a great explanation, actually, Micha. I think, and as Vijay says, each of these things can be taken independently, or obviously a multiplier effect if you use them all together.
Yeah. Okay, so let's move on to the final topic. Now we want to discuss about what's your opinion about other frameworks. So what do you think about React and React-based ClojureScript libraries, and what lessons that we can take from each other? And
yeah, I'm interested. I've been studying it lately a lot more than I had been for a while, and so I've been making some applications with Rum past few weeks, and with Reagent.
Yeah.
Exploring things, and like the thing that I'm most interested in, like the overarching goal, is the component story.
Yeah, especially with Reframe. I mean, that when we were discussing the web components thing, I think Reframe or Reagent-based thing, that they also want to build something similar, like different components, and yeah, it seems like a common kind of goal.
Yeah, and like the specific kind of things that we want to support is like, for example, in Hoplon, there's this macro Defn plus, which allows you to make a component where you declare attributes and you can accept children. It acts like a function. You could call it like a function. Specify attributes, which are, like keyword value pairs, and, children are like if you nest things inside. But the idea of it is that this component is a first-class DOM element thing. So suppose I have a component that is some kind of list component where it has its own internal structure, and deep inside of it, it has like a container area where children are going to go. And when you add a child, it's going to be wrapped in all this stuff to make it like a proper child of this custom element, right? So what we want to have is like a real first-class implementation would provide, where I have a function over here that constructs one of these things. I pass it to another function, which can add children, add attributes, whatever. And normally what happens is if this thing is like 20 divs or whatever, and like the container is like deep inside, you end up just adding the children to the outermost div. It's useless. It's a leaky abstraction. So that's the kind of thing, that's like our overarching goal, because what we want to achieve at the end of the day is a system where you can construct your more complex things from simpler things, full fidelity, and then combine those with, like the state machines and Javelin cells, to assemble applications with zero architecting is like our own.
So what's your opinion on virtual DOM? Because I know that Hoplon is using jQuery, so it's not doing any virtual DOM optimization as far as I know. Am I wrong? Or do you have any plans for?
There's no virtual DOM as such. I mean, it does have some aspects of the virtual DOM, but like for example, Hoplon does allocation a little bit differently. So like how do you, with Hoplon you leverage static allocation as much as possible. It's very declarative. But sometimes you don't know at compile time how many elements a certain thing will have, like a table, say, right? So that depends on what comes back from the database. And the way Hoplon handles this is kind of like, I don't know, we saw this thing in Common Lisp called a fill vector. I don't know if it's exactly that, but it's similar. It's basically you have a pool which represents the high watermark of how many things there were, and you never destroy them. You have this pool, but the properties of each of these elements in the pool are formulas on the nth element in this vector of data.
Okay.
Meaning like, you know, if you have your flights, like you were saying before, you know, those are coming from a database. And so you might have n flights in view. And so there's n little objects. And each one of them is constructed by a constructor that exposes a formula for the nth item in this cell.
Okay.
And so like that cell can grow and shrink, you know, the items in there. So maybe there's 40 of them now, and maybe there's only 10 of them at, you know, t plus 1. So the 11th item now has null in its cell, right? And so what Hoplon provides is like it provides some things for managing this. And so the TPL macros, we call them, it removes those guys from the DOM but doesn't destroy them. It just puts them into a pool. So there's only 10 items in the table.
Yeah.
But the other ones are still alive. They're still wired up and everything. They're just in this pool. And so when your thing grows again, they go back into the DOM, and now the thing isn't nil anymore. Now it's the 11th item.
It has the value. Yeah, yeah.
Right, and so you don't need to explicitly handle a life cycle there, because everything just automatically works because you've simplified it, because you don't deallocate anything. So you don't need to like rebuild state. So like those are the kinds of things that I think virtual DOMs interfere with, because you're not dealing with a direct reference to the thing. You're dealing with like an intermediary.
Yeah, there is a different abstraction.
Well, how do you stop it? How do you stop it getting out of control, or in terms of memory and stuff like that?
Like we've made some like really large applications now. Like the AdZerk one is pretty huge in terms of like functionality, the number of screens and so on. And it's totally not a problem at all, because like humans can't handle more than a certain number of things at any given time. And so like allocating some divs, like allocating 100 divs, like a lot of times because of the way it works, you can reuse those divs. So like a lot of times we can reuse the same table for different purposes. If it has the same structure, it's just a matter of changing what's in this vector of data, right? And all the things update. Okay. So in practice, you never run into that kind of problem. But
okay, so it's like a mini. It's like not a virtual DOM. It's like a virtual, like a mini DOM, like a virtual set of elements.
Yeah.
Or a pool of elements. Yeah. Like you said, DOM element pooling, basically.
Yeah, and you can make it lazy a lot of times. I mean, there are constructs that allow you to delay initialization of these things until the vector becomes non-nil, which allows you to like, sometimes it's good, sometimes it's not good, but it allows you to not have to load everything at once.
Okay. And what is the story about native Hoplon? Like nowadays, it's everybody wants to write ClojureScript or just writing JavaScript and run it everywhere. I think it's like Java of the 90s. I think write once and run somewhere.
Right.
So JavaScript is now everywhere, all the way from the server to the mobile applications that people are building with JavaScript. And do you think Hoplon can be used for the native applications, native mobile applications, for example?
Yeah, I've personally made a number of applications that are, in the App Store or whatever with Trigger.io in the past, and Cordova and stuff. And I haven't done anything in that area for like past couple years. But my view is that like I bet you HTML containers are just going to get better and better. So like I think the benefit, like I've been reading a bunch of stuff from like game engines and stuff about like native engines versus HTML5.
Yeah.
And I don't know, it seems like it might be that the future is not with, native shims, but might be with just HTML. I don't know.
Yeah, it could be, because I know that with every iteration, I know
Canvas,
they remove more and more restrictions from the WebKit, for example, on iOS. So the web view becomes way more powerful than the previous one, because previous versions they had a lot of problems because the touch events had a specific delay when
Right.
you use it on the app, and that made all the wrapper applications behave like shit.
Yeah, the 300 millisecond thing.
Exactly. Once it is gone, things have started getting better. So, but that's
Yeah, also, I guess the WebGL is also the other big thing, isn't it? Because now they have WebGL on there, so you can actually program on the web as well as on the native graphics stuff. I don't know I guess Hoplon has not really got a good WebGL story, or am I wrong there?
I haven't done any WebGL stuff, but like I've done SVG stuff, and that works fine.
Right.
Works awesome. Canvas, done some of that too. Works fine.
Yeah. So it is pretty much decoupled
right.
from the whatever kind of UI you want to use.
Yeah, I mean, SVG was especially like well suited, I think. Alan and I made some games, and it was like an interesting process because we offloaded all the stuff that you would normally need like a super quick render loop for. The stuff that React usually says like, oh, look at all this perf, you could do 60 frames per second. But like generally what we did was we found, we used SVG animations, transforms, things like that, and there's like tons of like highly optimized JavaScript libraries that you offload that stuff onto, and you actually only need to update your state and some trajectories and stuff,
Yeah.
Did you make a game to launch the nukes?
Yeah, it was actually Missile Command.
Oh my god.
Okay,
we got the theme, that's for sure. Okay. Well, that's brilliant. I think that's really fantastic. I don't know if you've got anything else that we want to talk about, Misha, or anything else that you guys are up to.
Yeah.
Oh, sorry, VJ.
I have one
last point.
The basic question is, so how do people hop onto Hoplon bus?
Ooh, I like it. Yeah.
Yeah,
So-
just hoplon.io is the website.
That's it. Okay. Of course, you guys are on IRC
Slack.
and Slack, and
Yep.
there is a Slack channel, and of course, your code is everywhere on GitHub, and people can follow you on Twitter, I suppose. So.
Yeah, I don't tweet very much, but I do have a Twitter, so.
Okay.
But yeah, the Slack channel
Yeah.
is the best place. There's a lot of really friendly people in there from all over the world, so like pretty much 24/7 support. So.
Oh, that's sweet.
Yeah, I think it's actually I've been in that Slack channel as well. I think it's always it's like the warm pool of the Slack team.
It's like
very
everybody's
nice,
sitting in
yeah.
a jacuzzi.
And it's a spa. Yeah, it's like it's quite literally. See, it doesn't matter. Okay. Yeah, but it's really nice. And also the other thing that I've done as well in the past is looked at the examples that you've got for Hoplon and Javelin and Castra, and using those examples to get started is a very good way of bootstrapping yourself and into the technology, I think.
Yeah, we have like 30 demo applications or something. A lot.
Okay.
Yeah, it's really
So
good.
that was it was very nice talking to you, Misha. Especially we are very grateful for you to you've been very kind and spent a lot of time with us. I know pre-show discussion also extended quite long.
This is the longest show in our
Exactly.
history, by the way, by a mile. So you've done something right there, Misha.
Well, thanks for inviting me. I'm having a great time.
And of course, it's our thanks goes to Alan as well. Both of you guys have been making amazing stuff. So we hope you guys are going to continue with these things, and and more people will. I'm going to use the pun again. Hop onto Hoplon, and
Thanks for
we're going to have much more fun. So thanks a lot, and
Maybe you've got a new slogan there for
hop
you,
onto
Misha.
Hoplon. Yeah, please go ahead. Please use it. And every time for every
We've got a trademark.
Exactly. For every impression, you can send me €2. Okay, that's you guys are in the ad business, right? You know how this works.
Yeah, we'll work out a deal. We'll work something out.
Yeah. But I mean, unfortunately, I couldn't do much with Hoplon. But after this discussion, I'm really curious because I built most of the web applications that are used in very closed environment, so to speak, like business applications. And I've been trying a bit with Reagent and Reframe. And of course, I would love to try it out. And I'll again hop onto Hoplon and onto your channel. And it seems to be very, very interesting, by the way. So thanks a lot. And any last words for us? Oh, by the way, Emacs or some other crap?
Yeah, I'm a Vi guy.
God. Okay, that's not bad actually. I think it has been tradition for one episode to ask.
Man,
people.
I spent like a year and a half with Emacs and Spacemacs and that stuff, and I tried to like it so bad, but I couldn't, man.
Yeah. Well, I'm on Spacemacs, but so how friendly is Hoplon development with Emacs now? Is it okay? Can I just plug in? Because I am assuming I just use boot and then just hook into it. Okay, but that's probably a different thing.
Yeah, our workflow is a lot more kind of like fig wheel style than REPL style, like my own personal one.
Okay.
Just because of the way like cells and spreadsheets work, you don't need to do the same kind of debugging as like I normally would in a Clojure program where you're calling functions a lot.
Okay.
Okay,
but we'll certainly do another episode about build tools and everything and boot, and we'd be very happy to have you or Alan on the show again. So we have lots of things to discuss because you keep producing amazing libraries, and we need to talk about this stuff.
It's fantastic.
Okay, thanks a lot, Misha and Ray, and of course we promised we're going to discuss about concurrency and async, but we'll certainly pick it up in the next episode. We'll discuss.
That's the nice thing about async. See, it's
Exactly.
a promise that is doable in the future. We don't say when. Okay, we just say it's in the future. So it will be next time.
We did the request. We did put the request into the channel. So as soon as the other side is going to pick it up, we know we're going to publish it.
Yeah.
So that's
it's in the buffer
exactly.
at the moment.
So that's it. I think that's it for today. Or any quick updates, Ray?
Just to say at the end, we will post all the show notes and all the links to Hoplon. It's fairly easy, I think, hoplon.io. We'll post it onto Defn.audio, onto SoundCloud, all this kind of stuff. But I think, just like you, VJ, thanks very much again to Misha. It was totally fantastic. Great conversation. I hope everyone who listens to the show has as much fun listening to it as we had talking about it, and it's really good. It's a great technology. I'm a massive enthusiast for it, so I think let's, come on, guys, get on board the Hoplon story. Hop on
Yes.
to Hoplon.
Hop on to Hoplon.
I'm going to use it now. And so that's one thing. Just one final quick credit again to Pizzeri for the intro and outro music. Melon Hamburger, go and support him on SoundCloud. He's doing a great job. PTZERY. Okay, thanks very much. And bye-bye, VJ.
Bye-bye, Ray. Bye-bye, Misha.
bye-bye, everyone.